The volume of a closed cylinder of base radius x and height h is 500 centimeters cubed, or cubic centimeters. Now, let's think about a cylinder. So, if the radius is r and the height is h, then the volume is pi r squared h. So in this case, we've got 500, which is the volume, is equal to pi x squared h. And that means that h is equal to 500 divided by pi x squared. Show that the total surface area of the cylinder is given by this expression here. Now, it's a closed cylinder, which means it has a top and a bottom. So the surface area is made up of two circles, top and bottom, and the curved surface. Now, the curved surface of a cylinder, if you unroll a toilet roll or something, you find you've got a rectangle. And the top edge is 2 pi r, which is the circumference here, and the height is h. So it's 2 pi r h for the curved surface. So that's 2 pi r squared, x squared in this case. So this will be xh. So 2 pi x squared plus 2 pi x times 500 over pi x squared. So that's 2 pi x squared, which is that bit. And then 2 times 500 is 1,000. The pi's cancel. One of the x's cancels. And that's over x. So that's this part of the expression. So, given that x can vary, find the stationary value of a. I used s instead of a. So we can do that even if you couldn't show this expression, remember. So a is going to be 2 pi x squared plus 1,000 x to the negative 1. So dA dx is going to be 4 pi x. Take away 1,000 x to the negative 2. And we need that to be equal to 0. So 4 pi x is going to be 1,000 x to the negative 2. So remember, x to the negative 2 is x squared on the bottom. So x cubed is going to be 1,000 over 4 pi. So x would be, we're only really going to get a calculator answer out of something like that, I think. So we want the cube root of 1,000 over 4 times pi. So that's 4.301. And it was the stationary value of a. So a is going to be, need to substitute back into the a expression. So it's going to be 2 times pi times my last answer squared. Add 1,000 divided by my last answer. So 348.7. And what units is that in centimeters? So it'll be square centimeters. And we want to show that that is indeed a minimum. So d2a dx squared is going to be 4 pi plus 2,000 x to the negative 3. so x cubed, which is greater than 0 for any positive x, implies that we have a minimum